Hey guys, and welcome back to part 2 on arithmetic sequences for math methods. Let's just continue where we left off. So in the last video we just took a look at this final example with the kilometers, and now we're just going to take a look at some actual questions here. So determine the rule for an arithmetic sequence whose few terms are. So let's just take a look at A. So the first term, t of 1 is 3. We can see it's increasing by 4 in both of them. So 3 plus 4 gives you 7, and 7 plus 4 gives you 11. So we know our difference is 4. Now, it says determine the rule. So what that means is we've got to take our formula pretty much and put it in terms of a general expression for n pretty much. So our arithmetic sequence, the term depends on this index here. So if you want the second term, you substitute n equals 2 into here, and it gives you that second term. So what we're going to do is pretty much, alright, sub in the first term. So t of n is 3 plus n minus 1 times by 4. Distribute the 4, so you get t of n equals 4n minus 4 plus 3. And then t of n equals 4n minus 1. So that is your general rule for your arithmetic sequence. So if I put in n equals 1, I should get 3. So t of 1 gives me 4 times by 1, minus 1 gives you 3. If you put in t equals 2, you get 4 times by 2, minus 1 gives you 7. So we can see that starts to work, and you can check for the third one yourself if you wanted to. Alright, so that's for A. Let's take a look at B real quick. So B, we can see it's decreasing. So it's going from 3 to minus 1, so it's going by negative 4, and we can see it's also going by negative 4 here. So your first term is your 3, and your difference is negative 4. So exactly the same thing as before, rewrite the rule and sub in the information we have pretty much. So we're going to have t of n equals 3 plus n minus 1 multiplied by negative 4. So what we're going to get is t of n equals minus 4n plus 4, because negative 4 times negative 1 is a positive, plus 3. So our general rule, t of n is negative 4n plus 7. So if I substitute t1, it's going to be negative 4 times by 1 plus 7, which gives me 3. T of 2 gives me negative 4 times by 2 plus 7, which gives me negative 1. And you can check for the third one as well. So that is the general expression for B. Let's do the same thing with C pretty much. I'm going to move this stuff over the side because I don't know if I'm going to have enough room on this PowerPoint pretty much. Okay, so I'll move that there, and I'll move that stuff as well. So straight off the back, let's just look at the first term. So your first term, t of 1, is a half, negative half, sorry. And let's see how it's decreasing or increasing. So we can see it's going from a negative to a positive, and because it's arithmetic, that means it's increasing by, I think, 1? No, it wouldn't be 1, so it's going to be 1.5. So, no, 2 actually, sorry. Because the difference here is 2. Because if you go negative a half plus 2, that's going to give you 1.5, which is 3 on 2. So it's increasing by positive 2. So your difference is 2. Took me a bit to work out just then. And you can check with the other sequence as well. So if you go 3 over 2 plus 2, that should give me 7 over 2. Because 2 is the same as 4 over 2. So 3 on 2 plus 4 on 2. They've got common denominators, so we can add their tops. So we get 3 plus 4, which gives you 7 on 2. Okay? So we can see the first term is correct, and the difference is also correct. So now we've got to pretty much make a rule for this arithmetic sequence. So you rewrite the rule, t of n equals t of 1 plus n minus 1 times by d. So we substitute that information in. So t of n equals negative a half plus n minus 1 times by 2. So t of n equals 2n minus 2 minus a half. So t of n is going to be 2n, and then we're going to add these together. So negative 2 is the same as negative 4 on 2. So what we have is negative 4 on 2 minus 1 on 2, which gives me negative 5 on 2. So minus 5 on 2. And that is the general rule for C. Okay. Now, let's take a look with D. So D, it's pretty obvious. It's increasing by +2. The first term is -2, and your difference is +2. So now I'm going to move this stuff to the side so I have enough room for everything. I don't know why that didn't select. There we go. Move that there. And let's delete that. We don't need that anymore. Yep, so now we just write the rule again. So T of n equals T of 1 plus n minus 1 times by D. So therefore T of n equals -2 plus n minus 1 times by 2. So we get T of n equals 2n minus 2 minus 2. So therefore T of n equals 2n minus 4. And that's the general rule for D. Now it's pretty similar stuff with all of them, but it's just good to get that practice in, and you can see it works for every different sequence. Okay? Let's take a look at a question that I've picked here. So 8. The number of laps that a swimmer swims each week follows an arithmetic sequence. In the 5th week, she swims 24 laps. In the 10th week, she swims 39 laps. How many does she swim in the 15th week? So straight off the bat, we know the 5th term, so T of 5 is 24, and T of 10 is 39. And we want to know T of 15. And we're told it's arithmetic, so it's common difference increasing. So pretty much, we take a look at our formula here. T of n equals T of 1 plus n minus 1 times by D. Now, you can actually change this index here. It doesn't have to be 1. It can be any number. So you can actually rewrite this formula like this. T of n equals T of q plus n minus q times by D. As long as this term is before T of n. So, for example, if T of n was T of like 10, that means T of q must be at least T of 9. It cannot be the same term or greater, pretty much. Otherwise, the math doesn't work. Okay, so what we can do here is actually we can choose pretty much two of these. So we can substitute this guy for T of n, and we can substitute this guy for T of q. So in other words, we can rewrite it like the following. We can write, alright, T of 10 equals T of 5 plus, and wherever the n is, you replace with a 10 now. So plus 10 minus, and wherever the q is, you replace with a 5, and D. We know what T of 10 is, and we know what T of 5 is. So therefore 39 equals 24 plus 10 minus 5 is 5, so 5D. And we're going to solve for D. So move the 24 to the other side, so you're going to get pretty much 39 minus 24 equals 5D. So 39 minus 24 is going to give me 15. So 15 equals 5D. Divide by 5, and therefore D is 3. So that means it's increasing by 3 laps per week. So what do we do with this information now? Well, we need to know how many she swims in the 15th week. So we can rub this stuff out so we have enough room on this page pretty much. So using our same rule here, we can choose T of n to be T of 15. So we can go T of 15 equals, and then we can choose either the 5th term or the 10th term for T of q. So I'll choose the 5th, so T of 5 plus, and now n is 15, minus 5 times by 3. We know what this guy is, but we don't know what T of 15 is because that's what we're trying to find out. So we get 24 plus 15 minus 5 times by 3. So 24, this is going to be 10, so plus 30 gives me 54. And it can work if I use T of 10 as well. So for example, T of 15 is the same as T of 10 plus 15 minus 10 times by 3. So 39 plus 15 is also going to be equal to 54. So it doesn't matter which one you pick, you can pick either one. Okay, so they swim 54 laps in week 15. Okay, let's take a look at our final question for the video and our final question for arithmetic sequences for this part. Okay, so the number of people who go to see a movie over a period of a week follows an arithmetic sequence. On the first day, only 3 people go to the movie, but on the 6th day, 98 go. Find the rule for the sequence and hence determine how many will attend on the 7th day. So, we've got the first term straight away, so we can use our normal formula here. So, we go, alright, T of n equals T of 1 plus n minus 1 times by d. So we don't need to change any index because we got the first term here. So T of 1 is 3, and now we also have T of 6 is 98. So we can substitute this information here. So we go T of 6 equals T of 1 plus 6 minus 1 times by d. Excuse me. So 98 equals 3 plus 5d minus the 3, so we have 95 equals 5d. Divide by 5, and then you're going to get, I'm not sure what that is, I'll use my calculator, d equals 19. So that means each day 19 people show up, pretty much, new 19 people. So it goes 3, then you add 19, which will give you 22, and then it goes on from there pretty much. So we've got that term. Now we've got to ask for the general rule of the sequence. So we can plug that information into there, and we're going to do pretty much what we did in this bit here, because we're finding that general rule. So we're going to have T of n equals our first term, which is 3, plus n minus 1 times by 19. So T of n equals 19n minus 19 plus 3. So T of n equals 19n minus 16. Okay. So if you want for the 7th day, you sub in n equals 7. So T of 7 equals 19 times by 7 minus 16. So 19 times by 7 is 133, I think, minus 16 is 117. So 117 people attend on the 7th day. And then that's that question done. I hope you enjoyed this video. If you want more topics on math methods, go check out the rest of them. This is just the first topic, arithmetic sequences. But yeah, more will be coming shortly. Hope you enjoyed.